So if you know that arc CB is 60 degrees, then you know that this central angle measure is also 60 degrees, because the central angle, so an angle with its vertex on the center, is always equal to its arc measure that it intercepts. So then you could use a linear pair postulate to figure out that this angle right here is 120, and then this triangle here is isosceles, triangle AOC. So if you're looking for angle A or angle 2, right, we already know measure of angle 1 is 60. If I just draw that out over here, AOC, this angle is 120, you got 60 degrees left, which makes these 30 degrees. Alright, so this angle 2 is actually 30. And that actually highlights something that we're going to learn in a later section. Alright, so just like in green, I highlighted that central angle. That means it's a vertex on the center. If your vertex is on the circle, that's called an inscribed angle. And inscribed angles are always half the measure of the arc. So like if this orange angle has its vertex on the circle and it intercepts an arc that's 60, it's going to be 30 degrees. Versus this green angle, which vertex is on the center of the circle, not on the circle, that's going to equal the measure of the arc. Alright, so that's something called an inscribed angle, which you don't even really need to know for these problems, but it's good to know for later. Okay, so angle 2, which you can't really see, that would be 30 degrees. Alright, so we could do the same thing for all of these. So like now, if arc CB is 70, this central angle is also 70. When the vertex is on the center of the circle, it's going to equal the arc. Alright, which makes this angle 110, which means 70 is left over for the two acute angles of this triangle, divide by 2. So this angle right here has to be 35. So you can use isosceles triangles, or you can also just use the fact that when you have an angle with its vertex on the circle, it's going to be half the measure of the arc it intercepts. Alright, so this would also be 70, and that would be 35. Okay, and that's 30, you got cut off. For the next one, right, if we know that this angle right here is 56 degrees, angle 1, okay, well then this arc is also 56 degrees because it goes both ways. The arc is equal to the central angle measure, and the central angle measure is equal to the arc. Alright, then you could subtract 56 from 180, and you get 124, okay, so you have 56 degrees left over for these two angles in this isosceles triangle right here. So that's 56 divided by 2, so you get 28 degrees. So angle A, or angle 2, is going to be 28 degrees. And again, it's always half the measure of the arc it intercepts. Alright, and let's just jump to the last one. Actually, let's not skip it. No, let's just do it. You can fast forward if you don't want to see this part. So angle 2 is 25 degrees. Okay, well, that means that this angle here is also 25 degrees because this triangle is isosceles. So that's 50 degrees, which means that this angle here has to be 130 because it's always going to be, the triangle is always going to add to 180. So this adjacent angle right here is going to be 50, which makes this arc 50. Alright, so again, we see that this inscribed angle here, which was 25 degrees, is half the measure of the arc. Alright, and then last but not least, okay, if this is x, then this angle is x, right, is given, because this is an isosceles triangle. So that angle right there is going to be 180 degrees minus 2x, okay, because it's got to be supplementary. Now, this angle next to it is going to be also supplementary to that, so it's going to be 180 minus 2x, because it's a linear pair. Alright, that simplifies to 2x, which means this arc is also 2x. So we see again that the inscribed angle is half the measure of the arc.